Okay, good morning, students. Am I audible?
Yes, sir. Good morning.
Right, so we will start. Wait for a while. Wait, students.
And because of that, there was a tsunami. This earthquake also has affected some of the coastal structures in Japan. In addition to that, this tsunami also hit on the coast of Japan. After that, there were fire incidents that region.
Okay, fine. So we were discussing this numerical, wherein this situation is given. This is the block, rigid block, and the angle of inclination of this surface, which is now it is now not the smooth surface, it is rough surface, and since we are incorporating frictional resistance, therefore the rough surface will come into picture. These are the axes. Okay, and the third case, in the third case, what is mentioned that the force P you are supposed to identify, which will just prevent the motion. Sorry, uh, if the force of P, which is 400 Newton, what is the amount and direction of the friction force? This is what you are supposed to identify. This P in case number 3 is given to be 400 Newton. And based on this information, you are supposed to identify in which direction this block will move. So in earlier two cases, it was mentioned that the block was moving either in the downward direction or the amount of force was applied in order to cause the upward direction. Okay, upward motion. Here you are supposed to identify if P is equal to 400 Newton, what is the amount and direction of the friction force? That means we need to first of all decide, before deciding the frictional resistance, we need to decide in which direction this will move. Okay, so how to deal with this situation? So whenever such question arises in which we do not know the direction of the motion of the rigid body, in that case, what you are supposed to do is first neglect friction. Okay, what we will do, we will neglect the frictional resistance, and based on that, I will draw the free body diagram. Okay, let these be the axis, horizontal x and vertical y. So what do you observe in such case when we neglect the frictional resistance? We have only the normal reaction. Okay, and the force which is mentioned P is equal to 400 Newton. Moreover, the self weight is given as 500 Newton. Okay. Now, if this is so, what we are doing, we are supposed to decide the direction of motion of the rigid body. So in order to decide that direction of motion, first of all, we will neglect the frictional resistance and let us try to find out in which direction the block will move if we neglect the friction. And after assuming the frictional resistance, what will be the change? That also we are going to study. So firstly, let us assume that there is no friction, and based on that, what do we have? What do we see? We have these two components. So being 45 degree, this is 45 degree angle. This will be 500 cos 45, okay, and this will be 500 sine of 45 degree. Am I right? Okay. Similarly, we need to resolve this inclined force. Now, in coordination with these axes, that is x and y, this is inclined force, and therefore this will again have its own component. So this will be P cos 45 and this will be P sin 45 component. Am I right? Based on this, what you do? Now you find out uh, the down plane component of the weight. What is the down plane component of the weight? Down plane component of weight, which is 500 Newton. Okay. What is the down plane component? It is 500 sine 45. Correct? 500 sine 45. What is this value? 500 sine 45. Please let me know. And similarly, up plane component of weight, which is 500 Newton. That will be, how much will be the up plane component?
500 cross 45.
No, how come? It is, whether it is in the upward direction. What I am saying? Up plane component. Here it won't be weight. Here, yes, that for weight it will be 0, but for this thing, for force, for the force P, which is 400 Newton. Now over here it will be 400 cos. However, it is, I mean, acting in the downward direction, but 400 cos 45 component. Okay. And I think this value, it comes out to be 353.56. Yes, 353.56 Newton, and this comes out to be 282.84.
Sir,
Yes.
sir, that vertical component of 500 should be 500 cos 45.
Whatever you take anything, you see, 45 being 45 degree, है ना? Sine component and cos component both will be same. Don't you feel so?
Yes.
है ना? So fine. So from these two values, what do you observe? What will be the tendency of the block, whether it will move in the upward direction or downward direction of the plane? Yes. So the tendency of the block, okay, will be to move in downward direction. Okay, in downward direction of the plane or whatever surface is given, right? So in this case, what has happened? This force, that is this component, which is up the plane, okay, this is less than whatever we have calculated for this. Okay, so you are okay, fine. Sine component cos, fine, because we are assuming here to be 500 cos 45. So here it will be 500, correct, this will be 500 cos 45, because this is what we are trying to identify, downward direction, down the plane component of the weight, and this is the up plane component of the force. So what do you observe? This value is less than this, and therefore the tendency of the block is to move in the. Now this is with respect to what we have considered, that we are neglecting the frictional resistance or frictional force, right? But from here we have now identified that the movement of the block is in the downward direction, since this down the plane component of the weight is more compared to the up the plane component of the force P, whatever is available. Uh, that means there is some amount of resistance which will be offered by this rough surface based on this motion. There is some amount of frictional resistance that will be offered, and what it will be? It will be nothing but the net force. Okay, so what you do? Summation of uh, summation of the forces in x direction should be equal to 0 in order to maintain the equilibrium. That means now we are trying to calculate the net force, frictional resistance that will be offered. Okay, so from this condition, what do we have? We have this situation. From here, we have identified that this block is going to move in the downward direction by the virtue of these forces, whatever forces are given or available with us. So these are the components of force, and these are the components of the weight, right? This is normal reaction. We are interested in finding out this frictional resistance as mentioned in your numerical. Okay, so this is what is the situation right now. Now, see, since the direction of the block is in the downward direction, therefore frictional resistance shall be in the upward direction. Let me call this to be capital F. We know the components of this force as well as this force. So we have called, or we have identified it as 400 cos of 45, and this is 500 cos of 45. Okay? This is what is the free body diagram, modified free body diagram for our next calculation purpose. So is this okay? Since the block is moving in the downward direction, friction shall be in the upward direction. So therefore, in order to maintain equilibrium, what I will say, this 400 cos of 45 minus 500 cos of 45 plus f equal to 0, and therefore f will be equal to, that will be nothing but difference between these two, isn't it? And how much does it come out to be? I am getting it to be 70.71. Okay, so this is the amount of frictional resistance or frictional force that can be identified if if the external force is given, no direction of the rigid body is mentioned. Okay, in such cases, you are supposed to identify the frictional resistance in this manner. So, is this okay with you people? Because the application of this shall be discussed in the chapter where when we will be discussing about the dynamics of rigid body. In that case, we will have to consider this concept. We will have to find out the direction of motion of several rigid bodies, because you will find in the in case of the dynamics of rigid bodies, you will find there are two or more rigid bodies. Those will come into picture, and those will move in directions, in different directions. So for that, we need to first of all identify what will be the frictional resistance. So this is how it has to be identified. Is this okay?
Yes, sir.
ठीक. So next numerical. Just wait for a while. I will join. Yes. Now there are two bodies which are resting on an inclined surface in this manner, and they are connected with the help of flexible rod, you can say. Okay. This is body A, this is body B. Inclination is theta degree. Coefficient of friction, these values are given for under two different bodies. So mu A is given as 0.2 and mu B, it is mentioned to be 0.5. 0.5. Weight of the body A, this is given as 200 Newton. This is 300 Newton. 300 Newton. Okay. These are the two weights which are given. You are supposed to determine the angle theta at which motion impends. Motion impends. Impending का मतलब क्या होता है? Just begin or just start. Just start. That means it has not achieved its final motion, but it is bound to start. Okay, this is known as impending motion. And when we say that any rigid body impends its motion, in that case, still the static coefficient of friction is applicable. Okay, so whatever frictional coefficient of friction over here is mentioned, it is nothing but static coefficient of friction. Right? So we need to first of all find out theta value based on these whatever information you can say is given. Right. So how to start with? Now try to identify whatever is given in this numerical. Firstly, you will see that rough surface is given, because of which the coefficient of friction values, those are mentioned. Secondly, these two rigid bodies, they are connected with the help of this string or rod, whatever, flexible rod you can say, that is been connected. That means this will have some force associated to it. Okay, so that force we need to first of all identify, take care of, right? Therefore, general tendency of these two bodies, how it will be, uh, whether it will move up the plane, because there is no external force which is acted upon. So what will be the general tendency of these two bodies to move the plane, on the plane?
Downwards.
Downwards, right? So let us consider that there is a tension force that is getting developed, and we will call it as capital T. Right? Some amount of pull is generated by the virtue of these weights. That is what we will consider. Based on this, let us try to draw the free body diagram associated to this. So free body diagram will consist of all the necessary information as far as external loads are concerned, forces are concerned, those will be represented. Okay, so this will be one of the external forces. Second will be the, now let us freeze on the axis. So we will consider this to be x, this to be horizontal to be x, this to be y axis. Okay, this will be like this, right? Then there will be normal reaction, correct? Here it will be normal reaction. Let me call this to be NA and this to be NB. Since the blocks are moving in the downward direction, frictional resistance in both the case will be upward, correct? We know mu A is given as 0.2. So since this is F max, this will become 0.2 times Na, and this again is F max, therefore it is 0. How much? 5 into Nb. This is what we have. One more information, that is of self weight. This is 200 Newton. This is 300. Now, so with respect to these axes, uh, what we can say, the weights are inclined. This is theta. This is what you need to identify. Okay, this is 200 and right. So can you please let me know if I draw these components? Okay, if I draw these two components, out of this and this, which one will be theta? So let me call this to be 1 and this to be 2. So out of this 1 and 2, which one will be theta?
Then two.
This one, because you can see from this geometry, if I extend this thing, okay, this one you will appreciate this angle will be theta, barabar hai? Similarly over here this one will be theta, so these are alternate angles, so this will be theta. Got it? So if this is theta, that means this component, what it will be? 200 cos of theta, am I right? And similarly this will be 200 sine of theta. Likewise, this will be 300 cos of theta, and this will be 300 sine of theta. So what we have done, we have drawn the free body diagram associated to this problem statement, and now it is just a matter of calculation that we will be finding out the unknown parameters, right? So we will go step by step. We will see first of all the free body diagram of A, FBD of A. Summation of forces in x direction equal to 0. See why we are in a position to apply the equations of equilibrium, since F max is achieved, right? Therefore, how many forces are there? 200 sine theta, which is in the negative direction, negative x direction, plus 0.2 times Na, correct? Then, what else for this? Plus T equal to 0. Am I right? Correct?
Yes, sir.
Similarly, summation of forces in y direction equal to 0. Minus 200 cos theta downward plus Na. Anything else? Equal to 0. This is for FBD of A. So, are you in position to find any of these terms out of these two equations? It is not possible because there are three unknowns, theta, Na and T. At the max, what we can say, Na is equal to 200 cos of theta. This is the equation what we can get from these two, rather from equation 2. And let us try to see that whether this equation can be used elsewhere. Then let us see for that FBD of B. From this FBD, we have summation of forces in x direction equal to 0 equation. In that case, it is minus 300 sine theta plus 0.5 times NB positive minus T equal to 0. Let's say equation 3. Then summation of forces in y direction equal to 0. Minus 300 cos of theta, which is downwards, plus NB. Again, from this I can get NB 300 cos of theta. So, what you can do, you can substitute this Na and NB, Na and NB values in equation number 1 and in equation number 3 respectively, so that you will get these two terms in the equation of sine theta and cos theta, as you can see from here. So let's say this minus 200 cos of sorry, sine of theta plus 0.2 times, how much is this value? 200 cos of 200 cos of theta plus t equal to 0. Let me call this to be equation 5. So what I have done, I have substituted this value in this equation, and I will now substitute this value in this equation. So what I will be getting, 300 sine theta plus 0.5 times 300 cos of theta minus t over here. Add these two. Okay, you can add these two equations and solve it. Or what else you can do is, yes, you can, I mean, either solve this, you can add these two terms so that t will get eliminated, and later on you can find out the values in the form of sine theta and cos theta, sine theta, cos theta, and from here you can even calculate the theta value. Can you do that?
Yes, sir. Sorry, we studied 20.81.
Theta comes, yes, 20.80, correct. Theta comes out to be 20. And from this, can you please calculate T value, tension value? Just substitute the value of theta in any equation and you will get T value.
33.69.
33.7, correct. T is 33.7. Correct. Good. Then next, one more numerical. In this, again such situation that there are two bodies and these two rigid bodies are connected with the help of again a string or cord like this. Over here there is a pulley. Like this. This is slope is mentioned, 3 vertical, 4 horizontal, and there is one more information. Find the least value of force capital P that will just start the system blocks to move. Okay, so you are supposed to identify, let's say, force to be capital P, P minimum. Okay, P minimum value, which will just start the system of blocks moving to the right. P minimum should be such that this complete system should move to right. That means in this direction. Okay. Coefficient of friction under each block, mu s under each block is given as 0.3. This is what is given. So what is mentioned? And see other things, pulley and all, nothing is given. That means you are supposed to consider this pulley frictionless. Unless and until it is given, you are supposed to consider everything to be frictionless. So since P minimum value needs to be found out, what is done? Let me consider this P value like this, inclined. I don't know the final position of this, but I will be assuming it to be inclined, and I will consider this angle to be alpha with respect to the horizontal. This is done because we need to calculate this. And why so? Because we are supposed to calculate this P minimum value. That's why. This will satisfy this equation, right? Now the blocks weight are given as 200 Newton and 300 Newton. Very quickly I will draw the free body diagram. Later on you can solve it. So the free body diagrams shall consist of these things. This one, this one. Let me consider this to be x and y axis, and this to be x and y axis, x, y, x, y. Okay? And this string will consist of tension force. Let it be capital T, and this will be constant throughout. Why? Because this pulley is frictionless, right? Let me call this to be block A and this to be block B. So this will be Na. This normal reaction shall be Nb. Now one thing is that this complete system is going to move in the right direction as mentioned in the numerical. That means the frictional resistance shall be in the opposite direction. Frictional resistance shall be like this. Okay. So this will be 0.3 times Nb. Now what will be the direction of frictional resistance in this case? कैसा रहेगा? Upward रहेगा या downward रहेगा? Because this is inclined surface. It will be downward. Correct. It will be downwards. And what will be the value? 0.3 times Na. This is 200 Newton. This is 300 Newton. Okay. This is the complete picture of the free body diagram. You are now supposed to solve this numerical and get the value of P. Okay. Take up this as your homework, you can say. Okay. Not an assignment. Take this as your homework. And in the next class, just let me know what will be the value of P. Okay. I will stop here. The syllabus of your test 1 examination will be up to equilibrium. Friction will not be asked. ठीक है? Up to equilibrium. शुरुआत से जैसे some theoretical aspect, that is some definitions, axioms, etc. All these things plus the resultant of force, then moment, couple, and equilibrium. Up to this, the syllabus will be for T1. Okay? Friction will be in the next part. Is this okay? I will stop here. If you have any query, please ask. Otherwise, you people can leave. Thank you.
Thank you, sir.